Hello guys, in this video we look into the process or into the cooling curve. Okay, for example here we bring you a naphthalene cooling curve. Okay, we look into the cooling curve or the heating curve. Okay, both of them, cooling and heating curve. For example, we bring a naphthalene. Okay, here we have an example for a heating or cooling curve. So is it a heating or cooling curve? As you can see here, okay, from time to time, from zero, okay, here is our zero, okay, let's say the time here initially zero, and then we increase in time. What will happen to temperature? Temperature will increase. Okay, so here is a heating curve. Okay, this is heating curve. Temperature raise as the time increase. Okay, so what is the information that we can get from this kind of heating curve? Okay, the first information that we can get from this diagram or from this heating curve, first we can know the melting point of this substance. Okay, let's say this is our curve, and then we have this kind of curve. So at this point, okay, let's say here given 80 degrees Celsius, okay, in your graph, in your curve here. So 80 degrees Celsius. So from B to C, okay. So this point we call it as the melting point. Okay, melting point. So melting point is where the phase of the substance of solid, okay, solid start to change into liquid. And how can we identify this melting point? Okay, if we have a heating curve, is this first you must recognize this area, okay, where this is the flat area, flat line, okay, flat line or horizontal line. First it must be horizontal line. Okay, what does it mean by horizontal line? So at B here the temperature is 80. At C temperature is also 80. That means the temperature remain the same. Okay, the temperature remain constant. There is no change in temperature. Okay, the temperature is not changing during the process. So whenever you see this kind of horizontal line, so that means you can find the melting point there. Okay. Next, what we have is the boiling point. Okay, we have the boiling point. So given there is 218 degrees Celsius. So how can we identify that kind of that boiling point? Okay. First, of course, it should be a flat line or horizontal line. Again, why do we need this horizontal line? Just to make sure that the initial temperature, let's say at starting point is 218 and the final temperature 218 remain constant. Okay, there is no change in temperature. The temperature is not changing. Okay, 218 along the way 218. Okay, once you saw this flat line, okay, or horizontal line, and then it is the second flat line. Okay, so this is your first horizontal line, and this is your second horizontal line. So once you find this line, So you can determine the temperature, okay, the temperature where the flat line or horizontal line occur. So the temperature at that point we call it as the boiling point. Boiling point. So here melting point, and the upper one is the boiling point. Okay, what are other information that we can get from this kind of curve, heating curve? Okay, next at AB, so here you have AB. Okay, you can see here AB. Okay, from this one A to B. Okay, A to B, this region. So the phase of the material here we just have solid. Okay, we just have solids. Let me try to draw another diagram here. Okay, so this is our heating curve. Okay, and then we start at here, and then first flat line, horizontal line, and then temperature increase, and then second line, and then temperature increase. Okay, so let like that is A and B. So B is where the line start to become a flat line. Okay, remember we have melting point. So here is the horizontal line, meaning that the temperature remain constant 80 degrees from B to C. Okay, B to C, the temperature are always 80 degree Celsius. From A to B, okay, there is change in temperature. Okay, the temperature is not equals to, the change in temperature is not equals to to zero. So that means there is temperature rises throughout the process. So we cannot say that this is the melting point. Okay, so here during this process from A to B, what we have here is all of the atoms or molecules inside this area are in solid phase. Okay, all of them are solid. So we have complete solid here, A to B. Let's say from 0 to T1, maybe 10 seconds. Let's say 10 seconds. So from 0 to 10 seconds, all of these materials are in solid. Okay, maybe this is our material. So solid. And then from B to C, okay, when the melting point reached by this curve, or when this substance reach the melting point here, so at B, so we have some of the molecules, okay, some of the molecules or atoms inside this substance begin to break their bond. They begin to overcome the force of attraction between them. So maybe some of them already become a liquid, but not all of the molecules or atoms. Some of them are still in solid. So here from B to C, okay, in this square region, okay, we have both of them liquid and solid. And then from from C to D, as you can see here, there is raise in temperature. Okay, the temperature is increasing. So that means there is no latent heat being supplied here. Okay, there is no latent heat involved in this process. How can you see that? Okay, because there is change in temperature. The temperature is changing. So C to D, what we have here, okay, here we have at B, remember at B, some of them start to become liquid, And then when we move further, let's say this is 10 seconds, then this is maybe 30 seconds. Okay. So at 20 seconds, maybe half of the atoms already become liquid. And then 29 seconds, most of the atoms already become liquid. Once they reach this point C, or at 30 seconds, so at point C, we can say that all of the atoms or molecules already become liquid. Okay, already become liquid because we already supply a lot of energy to this substance. So all of the energy being used to overcome or to break the force of attraction between these atoms or molecule inside the substance. So all of them become liquid. Okay, become liquid from C to D. And now at D, okay, at D, where the boiling point is 218, okay, 218. So it will keep changing its temperature from 80, keep rising until they reach 218 degrees Celsius. Once they reach 218 degrees Celsius, what will happen to this liquid? So some of the liquid will gain enough energy. Okay, some of the atoms or molecule inside this liquid will gain enough energy to become gases. Okay, to become gases. But some of them still in the state of the liquid. So it is not completely gas or completely liquid. It is the mixture of gas and liquid. So the process will continue. Okay, gas will keep increasing while the liquid will decrease until certain point. Okay, until certain point here. So until certain point here. So at point E, okay, at point E, once they reach E, what will happen? That at point E, we can say that all of these liquid are completely become gases. Okay, that means we already supply enough heat or energy to overcome the force of attraction between all of those atoms and molecules in the liquid. So all of them already become gas throughout this curve. So that is how we can conclude this, or we can get from this heating curve. Okay, all of those information can be obtained from this heating curve. Okay, of course you can read all of those explanation in your module. Okay, from A, B, C to D. So heat supply increase the kinetic energy, so temperature rises. Okay, as you know that temperature is the average kinetic energy of atoms or molecule in a substance. Okay, so kinetic energy increase, temperature increase. So at A, B, C, D, E, F, as you can see there, temperature is rising. Okay, at B, C, D, E, okay, at B, C, where the flat line is, where the horizontal line is, B, C, and D, E, phase change has occurred. So here, the process of change of phase from solid to liquid, from liquid to gas. So here, the latent heat is absorbed. Okay, B, C, latent heat is absorbed. D, E, latent heat is absorbed. So why do the material need the latent heat? Okay, they require the heat to overcome the binding forces between the molecules. Okay, since they want to change from solid to liquid, so they need to break the bonding between the atoms. Okay, they need to break this bond, this force of attraction between molecules of atoms in the substance. So that is all about the heating curve. Okay, that is all that the information that we can get from heating curve. So I hope you can understand all of the explanation given in this video. If you have any question, you can ask me directly through Telegram or any other any other medium. So that's all, and thank you.